Here I'm asked to find an inverse function for f of x equals 1/3 the logarithm base 5 of x minus 1 plus 4. Right away, I know the inverse function of a logarithmic statement should be an exponential statement, so I hope to end up with an exponential function. But for now, I'm just going to follow our process for finding inverse functions. So I'm going to rewrite my function instead of as an f of x equals, as a y equals. And my next job is to swap x and y. The domain just became the range just became the domain, and now my job is to get y by itself. And I think that's going to be easiest to do if I write this so that it is a logarithm equals something. Because that way, I'll be able to use the definition of logarithm to rewrite this as an exponential function. So from here now, my goal is to get the logarithm by itself. So get the log base 5 of y minus 1 by itself. Later on in this unit, we're going to talk about solving exponential equations, and we'll do this repeatedly where we isolate the logarithm. So we're going to take 4 away from both sides. Because I'm just really thinking about solving for this, the logarithm base 5 of y minus 1. All right, so now, if I'm trying to get this by itself, let's multiply both sides by 3. So I get 3 times x minus 4 is equal to the log base 5 of y minus 1. This is really what I was trying to do. I got the logarithm part by itself. I can rewrite this as an exponential statement. 5 raised to 3 times x minus 4, which I'm just going to go on and rewrite as 3x minus 12, is equal to y minus 1. Let's add 1 to both sides. Y is equal to 5 to the 3x minus 12 plus 1. Finally, I'll write that as the inverse function. All right, and there is my final statement for the inverse function.